Hi everyone, welcome back to my channel. This is Mr. Budehas, your online math teacher. In today's video, you will learn combined variation. This is the fourth type of variation. In my previous videos, I already discussed the first type, which is the direct variation, second, inverse variation, and third, joint variation. In this video, I'll be focusing on combined variation. Let's start. Combined variation. It is a type of variation consists of at least two different types of variation, including inverse variation. This is a combination of direct variation and inverse variation or joint variation and inverse variation. The results of this type of variation are varied, wherein as one increases, the other two may either increase or decrease. For example, the time it takes to finish a task is directly proportional to the number of tasks to be done, and it is inversely to the number of persons doing the task. This illustrates a combined variation which is composed of direct proportion and inverse proportion. Of course, if you'll be given more tasks, you really need more time. But if there are many persons who are doing the task, the time will decrease. As the number of tasks increases, the time also increases. That is direct proportion. However, as the number of person increases, the time decreases. Now, this time is inverse variation. Okay, equation of inverse variation. It is the mathematical representation of a combined variation, depends on the variation statement. For example, the statement y varies directly as x and inversely as z. This is written as y is equal to kx over z, where k is the constant of the variation. Okay, let's try to translate some statement into mathematical equation. Number one, if m varies directly as n and inversely as o, the mathematical translation for that is m is equal to k times n divided by o. So this is a combination of direct and inverse variation. Another example, the variable r varies jointly as s and t and inversely as v. The translation for this is r is equal to k times s times t divided by v. And this is a combination of joint variation and inverse variation. Example on how to find the equation of an inverse variation. If y varies directly as x, inversely as z, and y is equal to 12 when x is 4 and z is 9, what is the equation of the variation? To find the equation of the variation, we are going to transform or translate first the variation statement into a mathematical sentence. The statement is if y varies directly as x, inversely as z. The translation for that is y is equal to kx over z. Then substitute the values of x, y, and z to solve for k. We have 12 is equal to k times 4 divided by 9. Then multiply both sides by 9. So we have 12 times 9 on the left side, which is equal to 108. And then on the right side, k times 4 divided by 9 times 9. 9 there is cancel. So we have k times 4 as the remaining. Then divide both sides by 4. So this is equal to 1k or k, and 108 divided by 4 is 27. Therefore, the value of k or the constant of the inverse variation is 27. Now, substitute the value of k using the original equation, which is this. Then just substitute the value of k, which is 27. Therefore, the equation of the variation is y is equal to 27x over z. And this is now your working equation. Let's try some examples about combined variation. Number 1. If y varies directly as x and inversely as z, and y is equal to 12 when x is 3 and z is 5, what is the equation of the variation? This is a combination of direct variation and inverse variation. But before I will solve this, I want you to pause the video for a while and try to solve it by your own, and then compare your answer later. Okay, our first step is to translate the variation statement into a mathematical equation. The statement is y varies directly as x and inversely as z. And this is now the translation. Y is equal to kx over z. Second, solve for k using the values of y, x, and z. From the original equation, y is equal to kx over z. Now we have 12 is equal to k times 3 over 5. Then, multiply both sides by 5. We have 5 times 12 is 60. And k3 over 5 times 5 is k3 because this is cancelled. That is just 1. And 1 times k3 is k3. K times 3 is 3k. Then divide both sides by 3. So we have 20 as the value of k. Then substitute the value of k to the original equation to determine the equation of the variation. We have y is equal to 20x over z. And that is the equation of the variation or the working equation. Example number 2. If D varies jointly as A and B and inversely as C, and D is equal to 20 when A is 2, B is 5, and C is 3. What is the value of D when A is equal to 6, B is equal to 7, and C is equal to 4? This time, it is a combination of joint variation and inverse variation. And we are not just going to find the working equation, but we are going to use that equation to find the value of D. Now, I want you to pause the video for a while and try to solve it in your own, and then compare your answer later. First thing to do is translate the variation statement into a mathematical equation. We have the statement is D varies jointly as A and B and inversely as C. The mathematical translation for that is D is equal to K times A times B over C. Second, solve for k using the values of D, A, B, and C. From the original equation, D is equal to KAB over C. Now we have 20 is equal to K times 2 times 5 over 3. 2 times 5 is 10. So we are now going to multiply both sides by 3. 3 divided by 3 is just 1, and 1 times k times 10 is k10. Then 3 times 20 is 60. And then divide both sides by 10. So we have k is equal to 6. And that's the constant of the combined variation. Third, substitute the value of k to the original equation to determine the equation of the variation. We have d is equal to 6ab over c. And this is our working equation. We are going to use this to find the value of d. Solve the unknown. The unknown value here is d. We are to find d when a is 6, b is 7, and c is 4. Using the working equation, we have d is equal to 6 times 6 times 7 divided by 4. 6 times 6 is 36. 36 times 7 is 252. Then divided by 4, we have d is equal to 63. Therefore, the value of d is 63 when a is 6, b is 7, and c is 4. I'm done with my discussion for today. I want you to solve these two problems under individual practice and comment your answers below so that I can check if your answers are correct. And that's all for today. Thank you for watching.